So, good morning, dear students. I hope you all are well, and I also hope that you are studying at home and enjoying the online classes. So, in the last lecture, we have taken the topic that is functions, and there I have explained you the meaning of function, its concept, domain, range, and real valued function, and what are the important points which should be kept in mind while finding the domain and range. So let us just have a quick recap of that important point which I have mentioned in the previous video. Okay, so in the at last I told you that the important points where I took fx upon gx as one function. Say for example, if you have such type of function, so what I told you that your denominator should not be equal to 0. Okay, this we have to keep in mind while finding the domain and range. This is the first thing. Second thing I told you, there should not be any negative term inside the root, because it won't be a real, it will go in the imaginary part. Okay, so that is what we have to keep in mind, that inside the square root there won't be any number like 4. So this should not be there. So we need to keep in mind certain things, because these things gives us infinite or unreal values. So that is why, and we are dealing with the real valued functions, so we need to keep in mind this thing. All right, now it's the time to start with the questions. So in this lecture we will take the questions of this. Okay, so let's see. So children, here I am taking 3 different types of question. Let's understand. If you can understand this, you can do the questions up to question number 9. Okay, so let's see first question. If fx is x square minus 2x plus 1, then find f3. Now what is the meaning of that? See, f3 you have to find. Means we need to put the value of this 3 in this equation, because fx is this one, we need to find f3. So at every place of x we need to put the value that is 3. So what we get, will get 9 minus 6, 3 plus 1, 4. So 4 is the answer. So how, see how they can change the wordings and can ask in a very different way. Like they will be asking you, see it is also given in the book, that is image of image of 3 under f. They can also ask you in such a way that image of 3 in f. So the same concept you have to use here. You need to put the value of 3 in this equation wherever there is x, and you have to get the value. That means what? This 3, this is 3. It is giving the image 4 here with respect to some function on it. So this is the meaning of this question. I hope you understand. Now let us go to the another question. If fx is 2x square minus 3, then find x if fx is 15. Now we need to find the value of x if the image, they are giving the image as 15. So we need to put in place of this fx, we have to put 15, solve it, you will get the value of x, then that will be the x. Now coming to this third question, fx is x cube minus 125, then find f3 into f4. Now again the same concept you have to use. First you find f3, then you find f4, and then take the product, that will be your answer. So these are the easy questions, I guess. Now let's move to the question which tells us about how to find the domain and range, that are somewhat important. See, these questions are already seen in 11th class, but due to the reduced syllabus we could not cover that portion. Alright, so we'll understand this, it's not a big deal, that topic is very easy. Okay, so let's see. Okay, so let's see. Find domain of the function. We need to find the domain of the function. We are given with this first question. Fx is equal to 3x upon 28 minus x. Now, as I told, as we have seen in the important points, this is a kind of fx upon gx function, where I told you that your gx should not be equal to 0. Okay, so we are given with this function. We need to find the domain. How the domain is written? It is denoted by d and subscript f. So I told you we are dealing with the real valued function. So here nothing should be unreal or infinite, right? So what we have to keep in mind while calculating the domain, we need to just take this gx, or we need to take this denominator, and we have to put this not equal to 0, and we'll go on and find the value of x, what we are getting. This says x should not be equal to 28. What does this means? If ever you put 28 here in this equation, you are getting denominator as 0, and it is going to infinite, hence will not take this particular 28 value, rest the whole real number is acceptable. Okay, so how to find domain, how to write domain? So domain is whole real number but except 28 from the positive integers, right? So that is how we write the domain. That means, what do you mean by actual meaning of domain? That means how much values this equation can accept, how much values of x this equation can accept, how many values we can put, how many values we can give to that. So that is how we wrote the domain, that you give whole real number but accept 28. So this is how we express. This is minus, and we write 28 in this curly bracket to show that whole real number except 28. So this is the final answer of this question. Now coming to this question, we have again the fx upon gx type of function, where we need to put denominator not equal to 0. Alright, so again x square minus 1 should not be equal to 0, x square not equal to 1, or x should not be equal to plus minus 1. Okay, so except this plus minus 1, the whole real number is acceptable. How come? Because if you put positive 1 here, so again it will be 0, and if you put minus 1, so again it will be a 0 quantity. That is how denominator should not be equal to 0. So domain will be the whole real number but except 1 comma minus 1. Okay, or else you can say 1 and minus 1 you may write. Okay, so like this you have to denote. So I hope you have understood this question. Now let's go to some more complex questions now. Now let's come to this question. We need to find the domain of the function. Also we'll find the range in this question only. So we are given with fx is equal to 1 upon root 3 minus x. So as I already told you, the denominator should not be equal to 0. So what we have to do? 3 minus x should not be equal to 0. Or what specifically what we want? Two conditions. First of all, denominator should not be 0. Also the root inside the root, the negative should not be there. Or are you getting this? Okay, so it's better that we take it should be greater than 0. Also not equal to, because greater than we don't want equal to also. So that is why we are taking root of 3 minus x. Okay, let me just take one question here in this. Under root of x minus 1. Say for example, if this is the question, this is an easy one, right? There is no denominator. So we don't have to think about that fx upon gx condition. But here, this is an under root. And as I told you that inside the root, there should not be a negative sign. So what? X minus 1 should be greater than 0, right? Because it should be equal also, doesn't matter. Okay, so the thing is, it should not give unreal answer. 0 is acceptable. 0 is totally okay for us because that is considered as a real number. Okay, but here the real number which is not a real number, a negative number inside the root. So x minus 1 should be greater than or equal to 0. Means x should be greater than or equal to 1. Alright, means we need to put the value here which should not be less than or equal to 1. Which should be less than 1 because, okay, you put x equal to 2. So you are getting one answer. So this is real number. If you put x equal to 1 here, 1 minus 1, 0. That is also okay. If you put minus 1, so minus 1 will give you minus of 2, which is not acceptable. Okay, so the domain here will be the whole real number, but they should not take less than 1, which means what? It should not take 0 also. If you put 0, so 0 minus 1 will be your answer. Alright, so whole real number except up from 0 to negative infinite. So negative infinite will be written here in the starting and 0. So now I am using this open bracket which says the whole real number. We know the whole real number. This real number is minus infinite to plus infinite. In this bracket, except this bracket, rest all the that means set of values can be the domain of this function. Alright, you understood this? Now let's come to this question. 1 upon under root 3 minus x. Here, first thing, this bracket should be greater than or equal to 0 acceptable, but being in the denominator, here I am not using this sign. Okay, so from here what can we say? Or else you just see to the question, just put the values and just see which number should not be kept. That is what if I take x equal to 3 here. So 3 minus 3, 0, and 0 we don't want. If I put 4, so 3 minus 4, which is in under root negative, so not acceptable. This means I need to take the values less than 3. Means if I put x equal to 2 here, so 3 minus 2, 1, root of 1 is 1. So this x will accept only the values which are less than 3. Okay, so less than 3 means what can we say? It will go in the negative integers. Okay, so our domain, what will be the domain? The whole real number except what? Negative infinite till, no, we don't have to take the positive, no, because negative it can take, negative it can take, but it cannot go further. So it should not be 3. So from 3 to the positive infinite. So the whole real number, but 3 to infinite it should not take. You can use this bracket also. This bracket is more correct here. Okay, so the closed bracket 3 infinite. Okay, can you just tell me that which bracket, or is it correct? This question I am asking you in the video. Okay, so just let me know what will be the answer. Okay, now let's go to some other questions now. Alright, I forgot to just tell you about the range of this. Okay, starting with this question. Okay, so how to find the range of this question? You know the meaning of domain. We have seen that whatever the value this x can take, that is the domain. Now whatever value we can get from all this, that means range, we can say the image. That we are trying to actually find the image. That means we are finding the image of this total digits, whatever the values of x can take. No, that is if x can take 1 to 3 only. So we are actually finding if this 3 values, that means on applying any function on it, what these 3 values give this as their image, and what will be their range. Okay, so we are going to see that thing. So see, this is also very easy to calculate. How? This is our fx. Fx is root of x minus 1. Let us consider this is equal to y. So y will be equal to this. We are considering this fx is equal to y. So y is equal to under root of x minus 1. Okay. Now you try to mold this equation in x is equal to fy form. That means as y is equal to, in terms of x is given, so let's find x is equal to in terms of y. So for that you just square it. So you will get y square is equal to x minus 1. Take minus 1 here. So x will be y square plus 1. So we got x is equal to y square plus 1. Now here you have to take this function y square plus 1. Can you tell me how much values the y can take? As there is no restriction of any denominator, as well as there is there we don't have any root. So here what can we say? The y can take the whole real number. There is no problem with y. If ever you put positive, if ever you put negative, 0, anything you put here, you will get a, that means a real number, not an unreal or some infinite number. So here what we say, the range of the function is full real number. That is how we write Rf is equal to R. Okay, you can make these two R some different kind of, here Rf, so we can make this R somewhat cursive. Alright, so coming to this question, now here also we need to find the range. Again, do the same processing. Y is equal to 1 upon under root 3 minus x. You take this denominator here and y here in the down, so it will be like this. Then square both the sides, so 3 minus x is 1 upon y square. Now take minus x square there and 1 upon y square here. So transposing, we got x is equal to 3 minus 1 upon y square. Now here we have the problem is y is in the denominator. So y square should not be equal to 0, or we say y should not be equal to 0. So here y should not be 0, otherwise you take any number in positive or negative, you will get some or the other answer here. Alright, so how we will write the range of this function? It will be whole real number except 0. So this will be the range. So that is how we have to find the range, like this. Okay, so let's see some more questions here. Okay, so now let's do the question of some range of the function. We need to find the range of this function. See, I saw in the exercise, they are asking just domain and range, and those questions I have given you the touch how you have to start. Okay, keeping in mind all the things which I have explained till now in the each and every question, keep those points in the mind. The exercise can be easily done. This I am taking the last question of the exercise, which is fx is equal to 2 minus 3 cos x. We need to find the range of the function. Now this is a trigonometric function. Okay, so there is some other criteria for solving this question. How? Here we don't have to go for the domain. Okay, here we have to go for the range. Now in the 11th class we have seen the range of the trigonometric functions in the trigonometry chapter, that the values of the, that means the range of sine is from -1 to 1, and the domain of sine is minus pi by 2 to plus pi by 2. Similarly, the cos domain, the domain of the cos is from minus 90 degree to plus 90 degree, and its range is from -1 to +1, both inclusive. So we know minus 1 cos x less than 1. In 11th class we have seen this is the range of the cos x. The values of cos x should lie between -1 and 1. Now what we have to find, what we have to do for finding the range of this function, we need to make this cos x as this one. I repeat, you need to mold this cos x according to your function, according to your given question. Now how? So as starting with this cos x, the coefficient of cos x is 3. So we need 3 here, and we have 3 sides. This is a 2 inequality, that means we have 3 sides. So we need to multiply 3 with all these things. So it will be -3 less than or equal to 3 cos x greater than or equal to 1. Okay, sorry, cos x, 3 cos x should be greater than or equal to -3, less than or equal to, sorry, 3. Okay, so we got 3 cos x. Now in front of this 3 cos x we have minus sign here. Okay, and we need to actually subtract 2 from all. So from all the 3, let's subtract 2. Okay, now this is what? Minus minus plus 2 plus 3, 5. 2 minus 3, minus 1. Okay, so as you can see, we got our main function. So in place of this we can write fx And as I told you, we always, for range, we always consider this as y. So in place of this, we can put 1. So here we got our range. Easy, no? That y will be greater than or equal to 5. Okay, but it should be less than or equal to minus 1. So in between this value, you have to write the solution set. Okay, so this will become your range. I hope you have understood. Now as I can see that in your exercise you have there are certain questions. Okay, let's take one more question. Wait, here we did one very wrong thing here. See, we subtracted 2 from each and every one, so the sign of the inequality will change. Here, as I felt that something went wrong, so just see, this will be this sign. As we subtracted 2, okay, or we need minus sign here. So you think in such a way that we haven't subtracted 2 here. 2 is not written. Okay, we use only negative sign. So for using negative sign, we need to change the sign of this inequality. Okay, so let's change the sign of this inequality like this, and here also. Now it's somewhat readable because y should be greater than or equal to minus 1 and should be less than or equal to 5. Now here, so the range will be minus 1 to 5. Okay, only this much, rest no. So we don't have to mention here r minus. Here only this bracket values are acceptable. Okay, so like this. Okay, now let's see the exercise. Now there are 24 questions. Please try to solve. Okay, and I hope you won't find any difficulty, and even if you get, you are free to ask. Okay, now types of functions we will see in the next lecture. What are the types of function? With the examples we will understand this. Identity function, constant function, equal function, zero function, monotonic function, they are very important, and we'll see this exercise. Okay, so till that, please do the practice. Thank you so much. Have a nice day.